Now we move on to something that you've probably never heard of called Thevenin's theorem. Thevenin's is another method of doing a circuit analysis where we can determine what the equivalent circuit, again, looks like so that we can do things like power analysis and relationships. So we're going to apply Thevenin's theorem to simplify a circuit for analysis and describe the form of a Thevenin equivalent circuit. We're going to obtain the equivalent voltage and the equivalent resistance and explain the terminal equivalency in the context of Thevenin's theorem. So we do what's called Thevenizing a circuit and trying to determine how we can do things like power relationships in a circuit. So let's look at some of the general forms. In the general form, this is what essentially a Thevenized circuit looks like. You end up with some equivalent resistance that we call the Thevenin's equivalent and the Thevenin's source that we call the Thevenin's source. In looking at this, you can see two different relationships here where we have an original circuit across the outputs. You can see we have the current and the voltage identified, the voltage taken across the source. And when we do a Thevenin circuit, we boil the circuit down and we actually create an equivalent circuit that will yield the same results. Well, you may say, well, then why bother? Well, you're going to see. So in simplifying a circuit by a Thevenin's theorem, what we do first is, in this case here, we're going to Thevenize it and determine the Thevenin's equivalent voltage source. So in this case, we've got a resistor, 1, 2, and 3, and a source. We're going to put a meter on it here. And the meter then would, in essence, be looking at the voltage across V2, and the measurement would be R2 divided by R1 plus R2 times the source. Okay, so that would be the Thevenin's equivalent voltage drop at the open output ports here. To find the Thevenin's resistance, we have to replace the source with a short. And of course, when we do that, R2 and R1 become in parallel, and R3 now is in series with R1 and R2 parallel. So the meter in this case would measure a Thevenin's equivalent of R3 plus R1 in parallel with R2. So in essence, we would end up with this Thevenin's equivalent circuit. So let's take a look at an example where we've got a load across an output, A and B. We've got two 100 ohm resistors, a 47 ohm resistor, a 22 ohm resistor, and a 10 volt source. So we want to find the Thevenin equivalent between terminals A and B of the circuit. So the first step is the voltage from A to B is V Thevenin and equals the voltage drops of V2 and V3. So it's going to equal those voltage drops right there. So looking from the terminals A and B, R4 appears in series with the combination of R1, 2, and 3 in parallel with each other. So we would end up with a Thevenin's equivalent of 141 ohms when we took all of these in series parallel with the source removed and shorted, and we would end up with a V Thevenin of 4.08 volts. Thevenin's equivalent depends on the viewpoint or the port that you're looking in, AB or BC or AC. It just depends on how you want to look into the output of a circuit. So if we take a look at doing an analysis, let's look at A to C. So Vthevenin from A to C would be R2 plus R3 in series divided by R1, R2, and R3 times the source. Shorting the source then, our Thevenin A to C would be R1 in parallel with R2 and 3 in series. So in this case, we would have the Thevenin equivalent from A to C as R Thevenin AC, Vthevenin AC. Now let's look at the same thing, but we're going to do just B to C. So for B to C, looking into that port, Vthevenin then becomes R3 divided by 1, 2, and 3 times the source. Okay, so at A to C we had R2 plus R3. Now we just have R3 because we're taking the output across R3. The R Thevenin BC then becomes R3 in parallel with R1 and R2 in series when we short the source. So now we would have R Thevenin BC and Vthevenin BC as our results. So in taking a look at a circuit here where we have three resistors, R1, R2, and R3, this is the original circuit. If we remove R3 then to do our Thevenins, we would end up with then a Thevenin equivalent of the original circuit then with R3 once we put it back on. So we would Thevenize the circuit by looking into the ports. So in essence, in essence, it would be R3 viewing the circuit. So our Thevenin would be R1 and R2 in parallel when we short it out, and Vthevenin would be R2 because we're taking the output across R2, R1 plus R2. Okay, let's go ahead and let's stop there. We're going to look at something a little different here, the Wheatstone bridge, and tackling how would we Thevenize a bridge circuit.